Hello, fourth graders. Today I would like to talk to you about finding variables. Variables are the letters that you sometimes see in number sentences or equations, and we're going to practice finding what those variables represent. We're going to begin with using addition and subtraction, and then in later videos we'll move on to multiplication and division, and then we will actually combine them in another video. But we're going to begin simply, very simply, with just trying to find them using addition and subtraction. Now, this might seem very easy to you at the beginning, but it's going to get more complicated, so pay close attention. All right, finding variables actually uses what we call algebra. You've probably heard that word before, but we're going to practice the very basic rules of algebra, and there's going to be two for our purposes that we're going to start with. There are two rules or steps that we're going to practice. The first step is to isolate the n. Now, when I say n, I mean the variable, the thing that is missing. We're going to call it n in this case during these problems, but in your problems that you're going to work, it could be anything. It could be an m or a j or an x or a y, but we're going to call it n. So that's the first one. So the word isolate actually means to get something all by itself, to get it all alone. And you'll see what I mean about that in just a minute. Step 2 is to get down to just one n. Sometimes you're going to encounter problems where there's going to be more than one n, like 3n or 5n or 12n, and we want to get down to just one n. In order to do either of these steps, we're going to need to use the inverse operations. And now inverse means the opposite. So we're going to use the opposite operation of what we see, and you'll see again what I mean by that in just a minute. All right. Let's start by trying an example. So here's my first example. N plus 3 equals 7. So what does this mean? This means that there is a number that when we add it to 3 equals 7. Now you're probably saying to yourself, well, gosh, I know what that is. That's 4. 4 plus 3 is 7. And you're right, 4 plus 3 is 7. And it does seem very easy. But I want to show you why this works. And to do that, we're going to use algebra. So let's look at this. When I say that I have an n plus 3, I can say that the n is not isolated. And it's not isolated because it's not by itself on that side of the equals. The n is not alone. It's got a 3 right next to it. It's got a plus 3. And we need it to be all by itself. Now, that may seem a little funny or cruel, but we really do want it all by itself. And I want to say something else about the equals sign. The equals sign up to now has always meant 4 plus 3 equals blank. Give me a number. But that's not really what an equals sign means. An equals sign actually means that the two sides of this equation are equal. They balance each other. Because equal sign comes from the word equal, where things are on the both sides the same. So we want to keep that in mind as we move forward. All right, so we want to isolate the n. So how are we going to do that? Well, we have a 3. The 3 is getting in the way. It's keeping the n from being by itself. So if we have something and we don't want it anymore, we need to try to take it away. So let's take away the 3. And how do we do that in math? Well, we take it away. We use subtraction. So the 3, I can take away from the 3, and that would make 0. And that would leave the n all by itself. But then what would the other side be? Now, hang on a second here. Something's not working quite right. I took away the 3, but n can't be 7 because 7 plus 3 does not equal 7. It equals 10. Something is really wrong here. So let's back up. Remember when I said that the equal sign meant things are equal? That means they balance each other. They are the same. So if I take 3 away from the left side of my equation, I'm unbalancing the equation. So in order to keep it balanced, if I take away 3 from one side of the equation, I have to take away 3 from the other side as well. So I'm actually going to take it away from both sides. And that's a really, really important thing to remember as you're doing algebra. Whatever you do to one side, you have to do the same thing to the other side. So let's look at what that does. 3 minus 3, that's 0. 7 minus 3, that's 4. So I took the 3 away on the left side. I turned it into a 0. That's nothing. That can just float away and go away because 0 could be there or not. It just goes away. And then on the right side, I have 7 minus 3. That's 4. So then what happens? Well, I can bring the 4 down, and I can bring the n down. And what I get is, since the 3 is gone now, I took it away, all I have left is the n, and then the 4 on the other side, which tells me that n equals 4. And you can actually check that and say, okay, if n equals 4, I can take the 4 and put it in the place of the n, and 4 plus 3, what do you know, that equals 7. So therefore, that must be right. Also notice that the n is isolated. It's all by itself. That's how you know that n equals 4, because if the n is on one side by itself and the number is on the other side by itself, then you know what n equals. Now, this may seem like a lot of work to go through to something that you could do almost immediately on your own in your head. And that might be true, but as we move forward, you're going to find that having this skill and being able to see things this way is going to be really important. So let's try another one. This time I'm going to give you n plus 7 equals 15. All right, we're going to follow that same step. We're going to try to isolate the n. I have a 7 with the n. I want to take away the 7, so I'm going to take away the 7. But I'm going to take away the 7 again on the other side to make sure that both sides balance. So 7 minus 7, that's 0. 15 minus 7, that is 8. So I can bring that n down, and I get n equals 8. And you can check that again. Is 8 plus 7 15? Yes, it is. 8 plus 7 is 15. And therefore, that's how we know we're correct. All right. Let's try this one. I have n minus 6 equals 14. All right, let's start doing the same thing that we did before. We have the n minus 6. I want to get rid of the 6, so I'm going to take the 6 away from both sides. And wait a minute. Negative 6 minus 6 is negative 12. Hold on. Is that right? That is right. If I owe somebody $6 and then I borrow $6 more, I don't have $0. I owe more money. That means I'm at negative, oh man, I'm at a negative 12. That's worse. That's worse. I'm getting things worse. So something is very, very, very wrong here. All right, so we're going to back this up. Let's back it up. Okay, do you remember at the beginning when I said inverse means opposite? We're trying to do the inverse operation, and the inverse means the opposite operation. So when we had a plus 3 before, we took the 3 away. I have a negative 6. I have a minus 6 here. So what do I need to do? I need to do the opposite. So I need to actually add 6 to both sides. And remember, whatever I do to one side, I have to do to the other. So now, negative 6 plus 6, that gets me back to 0, which is that part where I can just let it go away, leaving me with only n. And that means 14 plus 6, well, that's 20. So my answer is n equals 20. And you can check. Is 20 minus 6 14? Yes, it is. Absolutely. Therefore, I have solved this equation. All right, I want you to practice this skill today in your assignment. You're going to do it just like this. I know it seems like it might be a lot of extra work, but I really want you to practice it this way because that's going to be important as we move forward. And this is how you really can guarantee that you're getting the right answer. Good luck.